Hey, welcome to The Explainer. So today we're diving into a really big question. What actually is intelligence? There's a fascinating new paper that suggests we've been coming at this puzzle from completely the wrong direction, and its core idea might just flip everything we thought we knew on its head.
All right, so let's just jump right in. The first thing we need to grapple with is the core problem that has kept scientists and philosophers busy for, well, centuries. It feels like a simple question, but it's one of the trickiest out there. You know, we all kind of feel like we get what intelligence is, right? We see it, we recognize it in people, in animals, every single day. But the moment you try to actually nail it down, to give it a solid definition, it's like trying to grab smoke. It just slips right through your fingers. And so what you get are these kinds of definitions. And yeah, at first glance, that sounds pretty comprehensive, pretty smart. But if you really look at it, it's kind of circular, isn't it? It's basically just saying intelligence is the ability to use a whole bunch of intelligent-sounding skills in order to act intelligently. It's describing the symptoms, not the actual disease. And that's the big problem with a lot of the famous theories you've probably heard of. You know, things like IQ tests that measure this general G factor, or Howard Gardner's theory of multiple intelligences. They're fantastic for measuring the effects of intelligence, for putting it in a box, but they don't explain the engine. They don't tell us what's actually going on under the hood that makes it all happen. So the paper we're looking at today argues that this whole mess, this confusion, it all stems from one single, very natural assumption that pretty much all of us make about how our minds work. But what if that assumption is just plain wrong?
Okay, so let me ask you a question, and it sounds really simple. How do you know a dog is a dog, or that a chair is a chair? Seriously, how does your brain create these neat little boxes, these categories, that let you make sense of an infinitely complex world?
Now, the intuitive answer, the one most of us would jump to, is similarity. We figure we have some kind of mental picture of a dog, and when we see a new creature, our brain just compares it to that picture. If it's similar enough, boom, we file it under dog. And on the surface, yeah, that makes a ton of sense, but what if it doesn't? And this is exactly where the whole idea of similarity just falls apart. I mean, look at this. A whale, a bat, and a giraffe. Visually, they have almost nothing in common. One swims, one flies, one has a crazy long neck. Yet our brains, without even breaking a sweat, lump them all into the exact same category: mammal. Clearly, something other than simple similarity is at play. And if that's not enough, there's an even bigger problem. It's what you might call a computational nightmare. Just try to imagine your brain, for every single thing you see, having to shuffle through a mental library of millions of categories it knows, from democracy to doorknob to dandelion, just to find a match. It would be impossibly slow. You couldn't even cross the street. It's just not a workable system for a brain that needs to think on its feet. So, okay, if it's not similarity, what is it? What's the secret sauce that lets our minds carve up the world so effectively? Well, according to this paper, the answer's been right under our noses the whole time. And you're not going to believe where it's been hiding. It's in the word itself. Intelligence, it comes from the Latin interlegere. And what does that mean? It literally means to choose between, or to discern. The key isn't about finding what's the same. It's about spotting what's different.
So this, right here, is the absolute core idea. We need to flip our thinking. The old idea was that our minds are constantly hunting for what's the same, for patterns of similarity. The new idea, our minds are built to hunt for what's different. It's a machine designed for discernment.
Okay, so how does this actually play out in the real world? How does this focus on difference work in practice? Well, there's a game, and I guarantee you've played it, that shows this whole idea in action perfectly.
Right, the game of 20 questions. It feels like just a bit of fun, a party trick, but the paper argues it's actually something much more profound. They call it a semantic binary search, which is a fancy way of saying it's a super efficient algorithm for thinking, and it runs entirely on finding differences. Think about it. When you play, if I'm thinking of an apple, you don't just start guessing random things. Is it a car? Is it the Eiffel Tower? No, you ask these big questions that slice the world of possibilities in half. Is it tangible? Yes. Okay. You've just eliminated every abstract concept in the universe. Is it a plant? Yes. Now you've eliminated all animals and minerals. Every single question is a strategic move to find a key difference.
And this is where it gets kind of mind-blowing. Look at the efficiency here. A similarity search, going one by one through a million things, could take, well, a million tries. But this 20 questions method, this difference engine, it gets you there in about 20. It's not just a little faster, it's exponentially faster. It's the difference between walking across the country and taking a rocket ship.
And this leads to a really wild, almost counterintuitive idea. A category, like bird, isn't defined by the birds that are in it. It's defined by all the things it isn't. It gets its meaning from its relationship to everything else in the network, by its difference from mammal, from reptile, from insect. Concepts don't exist in a vacuum. They exist in a web of differences. Okay, so let's bring this all home. What's the big takeaway from all of this? If we really buy into this new framework, if we accept that intelligence is all about difference, how does that change the game? What does that mean for us? Well, for one, it gives us a new definition for intelligence that is just so simple and elegant, but also incredibly powerful. Forget all those other complex definitions. At its very root, intelligence is simply the ability to handle differences. That's it. That's the whole shebang.
And you can even see this as a kind of core algorithm for how we think. Almost any intelligent thing you do can be broken down this way. You have a goal, select the best option. From what? From the choices you have. And how? By respecting the constraints, which is just another word for the important differences in the situation. I mean, think about it. That's everything from picking what to have for lunch to solving a massive scientific problem.
And you know, this idea is already baked into how we think about the world. Take this famous quote, we've all heard it. Our whole concept of sanity, of cause and effect, is built right on this foundation. We intuitively know that to get a different result, you have to introduce a difference in what you're doing. So I want to leave you with one final thought, kind of a way to reframe things for yourself. If intelligence is all about handling difference, then what does that make failure? Maybe failure isn't really failure at all. Maybe it's just the moment you discover a new, crucial difference, a piece of data that you didn't have before that makes your mental map of the world just a little bit more accurate. That's a pretty powerful thought. Thanks for tuning in.